with our rinse temperature probe. I'm going to go clean out the graduated filament. We're going to be using hydrochloric acid solution, and this is 1 molar. That's the concentration. And we're going to be using magnesium strips. This is what magnesium metal. Now, magnesium metal reacts with moisture. So I'm going to go put a glove on before I mess with the magnesium metal. So now we're going to do the second part of the experiment, where I'm going to take 30 milliliters of hydrochloric acid. I will take a picture of the bottle so you can see it. And this is 1 molar in strength. 30 milliliters. We're going to put and I'm going to press collect and let this sit in the cup for at least 45 seconds so we can get a baseline temperature. Then I'm going to put a piece of magnesium metal in the cup, and we want to be careful when we handle magnesium because it will react with water. If you've ever watched Lost in Space, the television series, you know that it reacts with water or ice. So let's see, we have a good 45 seconds. I'm going to put it in the cup. I'm going to turn the computer around so you can see the data we're collecting. Now, the magnesium metal is fizzing in the acid. So a gas is being produced. And you can see from the temperature that in this case, the temperature of the water is going up. So the reaction taking place of magnesium metal and hydrochloric acid is exothermic because the temperature is rising. And I am stirring the reaction with the temperature probe, and we'll see how far up it goes. And I'm taking care not to put my face right over the cup because that would be breathing in a gas, and I don't know what that gas is. Well, I do. But you as a student wouldn't know what the gas is the first time you do this experiment. And now the magnesium metal is completely gone. It's completely dissolved. There's a couple things we need to do on the computer. And since I've put all my chemicals away, I'm going to take my goggles off and spend some time on the computer. So we want to rescale the axis to do minus 10 and 40. Oh, that's where it already is. Okay. So to analyze our data, I'm going to go to the statistics button, which if you mouse over the different buttons, the one that says 1/2 is statistics. I'm going to press on that button, and I want to do both the graphs. I'm going to click on Run 1 and Latest Temperature. I'm going to press OK. And then I get data boxes for each graph. And in the data box, it tells me the minimum temperature and the maximum temperature for each of these. So those temperatures will go on your data sheet. Now, for the first reaction, which is in the skinny kind of dark green line. The minimum temperature is your initial temperature. I'm sorry, the maximum temperature is your initial temperature, 29.16. And then your minimum temperature is 5.41. We don't need any decimal points past that. Now, for these reactions, we will take temperature final minus temperature initial. So for one of these, the final temperature is lower than the initial temperature, and we will get a negative value. Now, for this one that's in red, which is our second reaction, and the temperature went up, the minimum temperature is our initial temperature, 26.62, and the maximum temperature is 34.24. Now, 26.62 is our initial, 34.24 is our final temperature, so this one will be positive, 34.24 minus 26.62 will be our temperature change. And in this first experiment, our initial temperature is 28.16, which is initial temperature. The final temperature is 5.41, so it'll be. Okay, here's the magnesium going into the hydrochloric acid. You can see that it fizzes. Now those bubbles are hydrogen gas. And as we keep stirring it, you can see more bubbles. And eventually, we will no longer see the magnesium strip. So let me see if I can get a good picture of the bubbling. There you go, you can see the bubbling. Okay. I'm gonna go back out. And now the magnesium strip is completely gone.